Hello and welcome to another video tutorial about FreeCAD. In this video tutorial we are going to learn how to model this compression spring like it is shown here on the screen. We will therefore learn how to insert a helix within the part module workbench, and we will learn how to do a sweep in the part module workbench. We will do a sweep of a profile along a path in 3D. We will also learn how to install macros from a FreeCAD homepage to enhance FreeCAD with more capabilities and functions and features. And we will also talk about an alternative way to create a compression spring if it comes to CPU usage, which we will try to keep low. The version of FreeCAD I'm using here is the 0.15 stable release under Windows 7 64-bit. So let's get started. First I'm going to close this document here. I'm going to insert a new document. And if not already done, please switch to the part module workbench. And as you can see, you can insert part primitives, but you can also insert geometric shapes in 3D. Now let's use this icon here. And you can see a list of all the geometric primitives you can insert in 3D. For this case, we will insert a helix, and here you have the different parameters you can apply to the helix. Let's use a pitch of 6 millimeters and a total 8 of the helix of 60 millimeters, so that we get 10 complete turns of the helix. The mid radius of the helix should be 10 millimeters. We won't need a conical helix, so the angle could be 0 degrees, and we use a right-handed helix. That is okay with us. We could also choose down here a different position and a different direction if we like, but we will choose these values to be at default values, and we click on Create. And if we switch to Axometric View, we can see that the helix is inserted here. We close this dialog here, and then we will create a sketch of a circle, and then in the next operation we will sweep the circle along the helix in 3D. So let's switch to the Sketcher workbench. As you can see here, we will need a sketch on the XZ plane. So I click on New Sketch and choose the XZ plane. No reverse direction, no offset. I choose OK. I zoom a little bit in, and I'll do a circle. I make sure that the midpoint of the circle is set on the horizontal x-axis. I will give these 2 points a horizontal dimension of 10 millimeters, because that's what we set as value for the radius of the helix. And I will apply a radius constraint to the circle of 2 millimeters. And that's it. We close the sketch, because we already are fully constrained. And now we are ready to do our sweep in 3D. Therefore, we switch back to the part module workbench, and we click on the icon for the utility to sweep. So of course, as I said before, we need a profile and a sweep path for this operation. The profile we have is the sketch, so we can click on the sketch here to mark it and apply a click on this icon here to add the sweep profile. Now we will select the sweep path, therefore it is advisable to click in empty space to be sure that nothing is marked here, nothing is selected. We will click on the sweep path, and then we will click on these different segments. Each turn of the helix is at the moment one segment, so I have to do a multi-select here by holding down Control on the Windows system I'm using and clicking on all these turns. And when I say done, I want to create a solid and I want to enable a Frennet option. The Frennet option makes sure that the beginning phase here and the end phase of the operation, which will then be here, are coplanar. I say OK, and here we go. The sweep operation was done successfully. Now, as you can see on the left hand side in the tree view, the helix and the sketch are still visible. I can manually toggle the visibility by using the spacebar or using the right-click menu here. So now they are no more visible, only the sweep is visible in 3D. Now if we have a look at compression springs, which are used in real life, they are normally centered on a planar face here and a planar face here. Maybe they have a cylinder or something like that inside and maybe one outside to get some sort of centering, maybe you can say. And technically speaking, we want to make sure that the compression spring does only move along its main axis and does not move in any other direction. So therefore, we will insert two cubes and we make a Boolean cut with the compression spring modeled here to show this also in our 3D model. So I'm going to insert in the part module workbench a cube. I'm going to select the cube in the 3D view. I switch here to the data tab. I will give it a length of 25 millimeters, a width of 25 millimeters as well, and a height of 3 millimeters. So as you can see here, the position of the plate I just inserted is wrong. So I will select the cube and click here in the placement tab, and then I will click on these 3 points here to change the placement. I will change the placement in X direction by minus 12,5 millimeters, and in Y direction it's also minus 12,5 millimeters, and in Z direction is minus 3 millimeters. Okay. So if you have a closer look here, I chose dimensions bigger than the dimensions of the spring to be sure to have overlapping contours. Often with Boolean operations such as cut or fuse, especially with cut, you have problems if you don't have overlapping contours. If you just have contours which are equal, coplanar or things like that, you may be getting problems. So now I'm going to select the sweep. When I press Ctrl to do a multi-select and select the cube, and then I do a Boolean cut by using this icon here, and as you can see here, we now have a planar face here. So I will repeat now this operation here on top to have a complete compression spring. Okay, so now I'm inserting another cube. As before, I will choose the length to be 25 millimeters, the width to be 25 millimeters, and the 8 to be 3 millimeters. So now I will choose the placement to be in X direction, minus 12,5 millimeters, in Y direction, minus 12,5 millimeters. So now I'm centered here, and the Z direction should be 60 millimeter, because that's what we entered before as the 8 for the helix. I click on OK. I choose the cut. I hold down Control key on my Windows keyboard, choose cube 001 and apply a Boolean cut, and we are completed with our simple compression spring. So a real compression spring would have a finer pitch in the lower region and in the upper region than in the middle region. So to model a realistic spring as possible, you would need 3 helices to be inserted, and then you would do 3 sweeps, you would do a multifusion and your cut. You can also use a macro from the homepage of FreeCAD. The homepage is located at www.freecadweb.org, and the macro section, at least that's how I often reach the macro section, is with clicking on tutorials here, and within the tutorials you have macro recipes. When you click on that, you will get here a list of macros which you can insert in FreeCAD to get additional functions. So now I like to show you a macro FC spring helix variable. If you click on this, you get here a picture of how your spring could look like, and you get a complete explanation with everything like that, what you need to insert, and how are the different values combined with each other and things like that. Now to insert your macro within FreeCAD, there is also a tutorial on the FreeCAD homepage how to do that. I can now show you at least my method with using Windows 7 and FreeCAD, and Well, I do it like this. You have these icons here to record a new macro and to open an existing macro and to edit it or whatever. And the first thing I do is that I record a new macro. Let's call it test. I will record, and then I will press stop. And if I open this button, I have all the macros within my macro destination directory. I can here choose a new destination directory, and as you may already know, under Edit, Preferences, if you have a look at the different registers here, you also have a register named macro, and you have a macro path where you can see in which directory the FreeCAD stores, at least at the moment, its macros, and you can change that here. So I'm going to open and edit my test macro. I do select it here in the list, and I said, and when I say edit, and now I can select all those lines and delete them. And then I can change to my browser. I can mark all the text here and then copy it via the clipboard to the empty macro here, and then save the macro. And that's it. For running the macro, you just press on the label here, or you can place the macro on your own custom toolbar within FreeCAD. So that's what I wanted to show here. And now I wanted to show you an alternative way to create a compression spring. As you can perhaps imagine, this helix approximation here uses quite some CPU power. If you have a modern CPU and a modern PC and things like that, this may be not a problem. But if you have an assembly with a lot of springs and things like that, and a lot of internals and a lot of parts, maybe you are quickly running low on CPU power. So maybe you can start thinking about an alternative way to model a compression spring, and this way will not take so much CPU power as using the helix. To do this, I will create a new document here to show you this method. We will use the part module workbench, and we will insert a torus. The torus we will leave with its initial values at the moment of a main radius of 10 millimeter and the radius here of a circle of 2 millimeters. Now, when you have a look at the part design workbench, you will have here possibilities to create patterns, such as a linear or polar pattern, for example. But these operations are only meant for object transformations. You know, it is meant to have a pad or a pocket and then apply a pattern to the pad or pocket operation. Here we have a complete solid, which we want to do a transformation. We want to have an array of the solid, so we need to use the draft workbench, and there we have an array tool. It is this icon here on top. it creates a polar or rectangular array from a selected object. So we will select the torus, and then we will start making the array. Okay, so we select the torus, we click on the array tool, we change to the data tab of the array tool, and let's see what we will have as values. We don't want to fuse the different copies of the array. The axis is at 0, 0. The vector of the axis is pointing in that direction, that is okay. We have an angle of 360 degrees, that is also okay. The interval in x direction we set to 0, and also the interval in y direction we set to 0. We only want to have an interval in z direction, and the interval should be 6 millimeters. That's the pitch we used in the example of the helix spring. Okay. Now the number of copies in x direction should be 1. The number of copies in y direction should be 1. And the number of copies in z direction should be 10. So now we have 10 tori, or to say 10 rings here. If we now would insert our cubes in the part module workbench, let's insert the cube. Let's switch to the data tab. Let's say 25 millimeter by 25 millimeter by 3 millimeter. Let's correct the placement. In x we have minus 12,5. In y we have minus 12,5. And in z we have minus 3 millimeter. We say OK. We select the array. We multi-select the cube. We do a Boolean cut. We insert the second cube. And now we do again change the dimensions of the second cube to be 25 by 25 by 3 millimeters. And we change the placement of the second cube. We click here on these 3 dots. X is minus 12,5 millimeters. Y is minus 12,5 millimeters. And Z should be 54 millimeters in that case to be correct. And when we do multi-select the cut and then the cube, do Boolean cut, and that would be another way of, well, symbolically modeling a compression spring. Just to give you something to think about and to have as a second thought if you're running low on CPU usage. Well, we have reached the end of this lesson. I hope I could show some things, and please leave your comments and remarks on the YouTube channel, and well, maybe see you in another video. Bye!